Hello, everyone. You're welcome to my channel. Here we here we solve common interview coding challenges. So, as a programmer, if you are preparing for an interview that involves solving a coding challenge, you're welcome to my channel here. So, um, um, mostly coding challenges on leetcode. So today we'll be solving one of those common coding challenges, which is find first and last position of elements in sorted array on leetcode. So without wasting further time, we'll kickstart the process. So we read, said, given an array of integers norms sorted in non-decreasing order, find the starting and ending position of a given target value. So if the target is not found in the array, so we return this array, which is has two values, which is a range. We just return this -1 and -1. So with that, the logic understands that we couldn't find the target value. And there is this constraint that is here. You must write an algorithm with O log n runtime complexity. So it means that we have to solve it in a time complexity of O log n time. So in that case, what comes to our mind is using the binary search algorithm concept. Okay, so because binary search actually runs in O log n time, and as you can see, it's going to be yeah. So if we look at the examples that are given, we already told that it's sorted in non-decreasing order. That means it is either increasing or it's either increasing or it's maybe let me use the word flat. That means it cannot be decreasing. So if we look at the examples that we're giving here, we're given this particular array and we're given a target of 8, and we're told to find the first and the last position of the sorted array. So we are finding the first. Here we have a range of the target, which is here. So we return the index of the first and the last. So here we have 0, 1, 2, 3, 4. So 3 and 4. And that's how we got this 3 and 4 here. In this particular case, we couldn't find the target value here because looking at this, there's no 6 inside this range. So we'll return this. But first, we have to also do a binary search across this to see if we can find the target. If we cannot find the target, then we can return this. But in this case, we could find the target. So once we find the target, then that's where we have to like check where the first and the last value of the target value is on the array, and we return their index, that range basically. So just as I said, this is a binary search range question. So for us to be able to understand to solve this problem, we need to use we need to understand the concept of binary search. So if maybe we have forgotten how to use binary search, I will encourage us to maybe do a lookup and try to look at maybe try to refresh our understanding of how to work with binary search, and then come back here to continue. But if you still want, I will just give a brief explanation of how our binary search concept works, so you can still follow along if you want to. But understanding the concepts is very, very key. So I'll just give you a brief summary of how binary search works. I'll be using a sketch. Okay. I'll be using this sketch IO here. Currently, this is actually the first array, and this is the target value. The concept of binary search works in such a way that it will, first of all, we have to get the middle value. And once we get the middle value, we'll check if it is equal to the target value. If it is, we just return that target value. If it is not, we eliminate one side where the target value will not be cannot be found, and we focus on the other side. So it like a divide. We are dividing the array for each time we calculate. We are actually dividing the array into two parts until we eventually find the target value. So because of that, the time complexity will always be a log uh, 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 O log n time is not n time complexity. So if we do that here, so first we first of all identify our left index using a pointer. Then we identify our right index. So our left index will be the first one here, then the last one here. Now we have to calculate the middle value. Now getting the middle value, if I call that, let's say I call that m here. So m will be equal to, we'll sum both the left and the right values. So we have left plus right, and we divide by 2. So we divide by 2. So that will give us the middle value. And once we get here, sorry, I'm writing left and right. So here, let me write the index. So we have starting from here, we have 0, we have 1, we have 2, we have 3, we have 4, and we have 5. Okay, so these are the index. So to get the middle value here will be, sorry, I'm going to change this one to 0. And here I'm going to change it to 5. Sorry, I hope you understand. Yeah, I'm going to change it to 5. Yeah, I hope you get the logic. Yeah, I'm sure you understand what I'm trying to do here. So if we divide 0 and 5 by 2, that will give us 2.5. So we get 2.5, and we can actually round this up to 2. We round this up to 2. So this is the middle index, and if we count where the value is here, so we have 0, 1, 2. So our middle value will be here, okay, at 7. So using binary search, we can check if the middle value is equal to the target value. So here, the middle value is not equal to the target value because the target value is 8 and our middle value is 7. If the middle value is not equal to the target value, then if it is equal, then we just return that middle value. So it means that we have found the target value. But if it is not equal to the target value, we need to check the direction where the target value is, if it's on the left-hand side of the middle value or is on the right-hand side of the middle value. So in this case, we can, if we check, we see that the middle value is, the target value is 8, which is greater than the middle value. So it means that we can only find the target value on the right-hand side of the middle value. So in that case, we eliminate every values on the left-hand side of the middle value, including the middle value. But before we can do that, we have to move this left pointer to just in front of the middle value. So here our left pointer becomes here, and we eliminate everything here. So we are remaining with these values on the range. So we have actually eliminated almost half of, let's say half of the values on the array. So here we can now recalculate the middle value to see if it is equal to the target value. And if we do that, you see that our left pointer is 3, Our right pointer is 5. So 3 plus 5 divided by 2, that will be 4. And you can see this is index 4. So this is equal to our middle value now is now equal to the target value, and we'll just return that particular value. So we keep using this divide and conquer method until we get the target value. So this is basically the concept of binary search, and this is actually the concept we'll be using to solve our problem. So if we come back to the code, so we have to start coding it out. So the first thing first, we looking at this output here. So let's define our output. So we can say okay, so I say const output is equal to have the range. We have -1, -1. I think we will be using we'll need we'll create a helper function here that we'll use to make it easier for us to be able to solve this problem. So I will call my helper function the search range helper. So I'll write search range helper. So in this helper, we have the array, which is norms. We have the target, and it's going to take other parameters. But so let's quickly define the helper here. So let's know the numbers of parameters that we'll need to take. So I define my helper here. So I have function search range helper. I'm going to take the array, the norms. We have the targets. We are going to take the first index. We'll call that left here. The right index will be the last element in the array. So we call that right. We'll also take the output because we'll be modifying this output and returning it. Okay. Then we will need to include a Boolean so that that will help us define the direction, whether we are on the left, if we are working on the left side of the if we are working on the left side of the middle value, or we are working on the right side of the middle value. So we can default it first to the left side. So we can say, maybe we can call it go left. So by default, if it's on the left side, it is to be true. So yeah, so here. Okay, so we can add these other parameters here. So we can have the left side, so it will starting from 0. So that will be the left side. The last element in the digit will be call it norms dot length -1. And we have our output, which will be actually be modifying and returning it at the end. And we have the go left. So if we are on the if we are on the left side of the middle value, if you are working on the left side of the array, it will default to true. And when we reverse the direction, it will default to false. So we need to add that here. So we have to have another function that takes care of that. So we have a search range helper that takes a norms, takes a target, takes 0. So we have norms dot length -1. We have the output, and it takes false. Okay. Then we can return the output. Okay, so So once we have this, so we can start coding it out here. Okay, so we'll be using the iterative approach so that at the end of the day, we will not only achieve the n log n time complexity, we also have a constant space. Okay, so we're using a while loop. So while left is less than or equal to right. So we can write the code that will be running inside this while loop here. The first thing is for us to be able to calculate our middle value. So we have const mid is equal to we are using JavaScript, so I think we'll be using the math.floor. Maths.floor, and we have left plus right divided by 2. Okay, and here we have we have defined our mid index, and now we can start applying the binary search to find the target value. To do that, we'll start with say if our target, let me use this, if our target is less than the middle value, so we have norms not mid. Now, if our target is less than the middle value, we want to do something. So in that case here, we have our target value to be 8. If we have our target value to be 8, okay, and if we do the calculation here, our middle value will be 7. Remember, so this one will not fit in. Let me check for this one. Here we have 0, 1, 2, 3, 4, 5. So our mid index will be 2, because 0 plus 5 divided by 2 rounded down. So we have to have 0, 1, 2. So this our middle value will be 7. But our target value is 6 here. So it means that our target value is less than our middle value. So we have 6 less than 7. Okay. So in that case, we are looking for the target value, and our middle value is 7. So it means that for us to be able to get our target value, it has to be on the left side of the middle value, because this is already sorted, so it cannot be on the right hand side. So in that case, we need to eliminate everything on the right hand side of the middle value. So we eliminate all these values from here, and we move the right pointer to just we move the right pointer to the back, just behind the middle value. So in that case, what we'll have here, our right pointer will becomes right is equal to our middle value minus 1. Okay. So now we see how we got this one here. So if this is the case, else if if our target value is greater than our middle value, so we have norms dot mid here. So in that case, we have a scenario of this one where our middle value was where our target value is 7, and our middle value is and our middle value is 8. So yeah, so our target value was our target value was 8, and our middle value was 7. So in this case, our target value is greater than our middle value. So if that's the case, it means that we cannot find our target value on the left side of the array of the middle value. That's because we can only find it on the right hand side, because just as I said, it's already sorted. So it's already sorted. So every other, the values at the right hand side of the middle value are all greater than the middle value. So we will find it on the right hand side. So in that case, we'll eliminate every value on the left hand side of the middle value, including the middle value, and just move the left pointer to the front, immediately in front of the middle value here. So in that case, our left will be equal to mid plus 1. Okay. So that is how we'll find the left hand side. So if these ones will run, okay, so we have if, else, if, then else, else if we here now, once we are able to get our target value, now we need to be able to get the range of where the start and the end index of the target value, and then return it. So in that case, that's where we'll use this Boolean, the go left. So we'll say that if go left, okay. So if go left, so we'll be, first of all, we'll be concentrating on the left-hand side of the array. If go left, we need to check if where the start and the end index, where the start index on the left-hand side is, and where the start index of the left-hand side is, basically. So we can say if the middle value, the mid index, if it is equal to 0, so it means that it's already at the starting index. It cannot go left more than this. Or else if the target value, here we have the middle value that is not equal to the target value. So if we have norms dot mid -1. So let's say here we have gotten our target value to be 8, but remember we have 2 8 here, so we want to know where the starting 8 starts from. Once we can be able to define that, if we move leftwards and is not equal to the target value, it means that that's number, that target value, which that target value is actually the starting index of it's actually the starting index for the target value. So that is actually what we are trying to compare here. So if we move 1 behind the current target value and is not equal to target, okay, then we know that that is the starting index, and we just assign it to the output. So we have output of 0 is equal to mid, and we can return it because we are inside this particular while loop. So we'll just return it. Else, we keep moving to the left. Okay, so our right is equal to mid -1. So we keep moving to the left until it satisfies the condition. So that is what that. So else, we are now on the right hand side of the on the right hand side, we are trying to check the range on the right hand side so that we can be able to return the index. So else we check if mid is equal to the last digit in the range. So we have norms dot length -1. If it is the last digit in the range, so it means that we cannot go more right. So that's the last digit. So that is actually the last range. So we can return that. Okay. Or if the value that's the middle value that is not the target value, if norms dot mid +1, what it means is that once we get our target value, we are trying to get the other range on the right hand side. So if we move +1 that to the next available value, and we check that is no longer equal to the target value, it means that we have actually gotten that range, and we just return that index. So that's actually what we are trying to do here. So if it's not equal, so if it is not equal to target, so it means that we have found the range on the right hand side, and we can just assign it to the output. So we'll say output 1 is equal to mid, and we can just return it because yeah, we are inside the while loop, so we need to return it so that it can start running forever. Okay. Else we keep moving right, so we move the left pointer to just in front of the middle value. So we have mid +1. Okay, so that's I think is the logic. So this one will run, and we should be able to get the range for the first and the last position on the element. So let's try to run this and see if it will pass the test. So if I run this, okay, so as you can see, it passed the test, and yeah, so basically we are just using the binary search concept here, and once we are able to get our target value, we just check for the range. We check where the left index where it starts from, and we also check for the right index where it starts from. So if I could just recap here, here we just define, because we are told that if we cannot find the binary search, we just return -1 and -1. So we'll be modifying this so once so long as our target value is inside the given array. So we created this helper here, and in this helper we have the Boolean go left, so we default it to true, and on the right hand side it becomes false here, and here we created a while loop, and so long as the left is not equal to the right, we can our code will run. So in that case, we define the middle value here, and we compare. Here we are trying to find the target value, so we did all this, and once we know that, okay, we can get our target value, then we can start checking if we can get the leftmost index of the target value. That's what we did here, and also the rightmost index of the target value, and just return those indexes. So those are actually the range, basically. So that's the code for you, and let's try to submit this and see if it will pass all the tests. Yeah. So if I submit this, okay, yeah, it passed all the tests, and yeah, it passed. So that is the code, and that is it. And thank you for watching. If you have any questions, you can drop it on the comment section. And if you like this video, you can just leave a like. And if you are actually preparing for an interview that involves a coding challenge, you can subscribe to my channel. And if I upload new videos, you can actually be the first to see it. And thank you for watching, and I wish you all the best in your interview. Thank you.